Hello, my mathematicians. Today we're looking at Module 17, Lesson 1, which is all about understanding decimal division patterns. Hopefully, by the end of this lesson, you can use patterns to place the decimal point in the quotient. So, spark your learning. It says Jada is playing a sorting game with a deck of math cards. Each card has an expression on one side. She lays out 10 of the cards. Sort the expressions on the cards in the boxes. So, if we start with the first one, it says 752 divided by 100. Well, I know 100 is going to go into 707 times. So that means it's going to fall between 1 and 10. Then we have 936 divided by 1,000. I know that it's going to go into less than one time because 936 is less than 1,000. Then we have 842 times 10 to the second power. That means that we move our decimal point over 2 times to the right. So that's going to give me an answer greater than 10. Then we have 842 divided by 10. 10 is going to go into that about 80 times, more than 80 times, but so that's greater than 10. So we have 936 thousandths times 10. Means we move the decimal point over one time. It's going to be 9 and 36 hundredths, so it's going to be between 1 and 10. Then we have 93 and 6/10 divided by 10 to the second power, which 10 to the second power is the same thing as 100. 93 and 6/10 is less than 100, so it's going to be less than 1. Eighty-four and 2/10 divided by 10 to the second power. Again, 10 to the second power is 100. 84 and 2/10 is less than 100, so it's going to be less than. We have 7,520 divided by 10 squared, or 10 to the second power. So again, that's 100. 100 is going to go in there over 70 times. So we have 752,000 times 10 to the third power. We move our decimal point over 3 times. It's going to give us 752. So we have 852 divided by 10 to the third power, which is 1,000. So that's 842 is less than 1,000, so it is going to go here. Okay, so to build understanding, the factory making the math card ships a box with decks of cards to a warehouse. How much does each deck of cards weigh? How can you determine the weight of one deck of cards? Well, we would divide 275 by 1,000 because it weighs 275 pounds and we're dividing by 1,000. So dividing by 1,000 is the same as multiplying by what fraction? Well, it would be the reciprocal, which would be 1,000th. So what is the decimal equivalent of 1,000th? Well, it would look like that. So complete the pattern. We know that 275 times 1 is going to be 275. We know that 275 times 1/10 means that we're moving our decimal point one place to the left. Our decimal point starts at the very end of the whole number, so it becomes 275 and 5/10. Then we have 275 times 10 to, times 100th. And so that tells us we're moving our decimal point 2 places to the left. So it's going to give us 2 and 75 hundredths. And then we have 275 times 1,000th. Means we're moving our decimal point 3 places to the left. So we're going to have 0 and 275 thousandths. So write a pattern for dividing by 1, 10, 100, and 1,000. Well, it's going to look very similar. So we're going to have 275 divided by 1. It's going to equal 275. 275 divided by 10. Oops, not multiplied. Is going to be equal 27 and 5/10. 275 divided by 100 is going to equal 2 and 75 hundredths. And then 275 divided by 1,000 is going to equal 0 and 275 thousandths. So what can you conclude about the relationship between the patterns in parts D and E? Well, division by powers of 10 is the same as multiplication by 1 1/10 100th and 1,000th. So how much does each deck of cards weigh? Well, 275 thousandths pounds. A store receives and sells 1,000 decks of math cards. If the amount received from selling 1,000 decks of cards is $9,450, what is the price for each deck of cards? How will you find the price for each deck of cards? Well, we're going to divide 9,450 divided by 1,000. So then it says to divide 9,450 by 1, 10, 100, and 1,000 using numerical form and expanded form. So we're going to do numerical form. Divided by 1 equals 9,450. That would be the same thing as 9,450 divided by 10 to the 0 power. We're going to go 9,450 divided by 10. It's going to equal 945. That would be the same thing as dividing by 10 to the first power. We have 9,450 divided by 100. Remember, we're moving our decimal point 2 places to the left, and our decimal point in a whole number starts at the very end, so we're going to end up with 94 and 5/10. That's the same thing as dividing by 10 to the second power. So now we're going to do 9,450 divided by 1,000. Moving our decimal point 3 places to the left, starting at the end. So we're going to have 9 and 45 hundredths. That is the same thing as dividing by 10 to the third power. So how's the change in position of the decimal point related to the exponent for the power of 10? The number of places the decimal point shifts is equal to the exponent. How do the place values of the digits in the quotients in your pattern change as you divide by increasing powers of 10? They change by a factor of 1/10 for each increasing power of 10. So to find the cost for each deck of cards, how will the decimal point shift? Well, it will shift 3 places to the left. So what is the price for each deck of cards? It is $9.45. It says the factory making the math cards also produces game tokens. They sell them in packages of 100 tokens. Each package weighs 28 ounces. How much do 1,000 packages weigh? How much does one game token weigh? So, what expression using power of 10 describes the weight of 1,000 packages? Well, we would do 28 times 1,000. So, how much do 1,000 packages weigh, and how do you know? Well, 28 times 1,000 would be 28,000. Multiplying by 10 to the third shifts the decimal point in 28 to the right 3 places. So what expression uses a power of 10 to describe the weight of one game token? Well, it would be 28 divided by 10 to the second power. So how much does one game token weigh? Well, second power means we move our decimal point over 2 places to the left, so we'd have 0 and 28 hundredths ounce. That should be ounces up here. Dividing by 10 to the second power shifts the decimal point in 28 to the left 2 places. That is all for today's lesson. Hopefully you are now able to use patterns to place the decimal point in a quotient. And remember, in order to be a math person, all you have to do is be a person and do math.